To investigate whether there's a relationship between two variables, you'll want to use a correlation. So in this example, I'm going to be correlating or looking for a relationship between quiz 1, or how students did on the first quiz in a course, and final percent grade in the course. To do a correlation, you go into Analyze, Correlate, and then Bivariate. In the dialog box, you simply have to put both variables into the variable box. And down here you can select a different correlation coefficient if you would prefer that one, but we'll be using Pearson. And it will also allow you to choose a one-tailed or two-tailed test. We will leave that the same. In Options, you can request the means and standard deviations. Otherwise, you can leave everything else the same. And then press Continue. And then press OK. This will pop up two boxes. In the first one, you just get the descriptive statistics for both of the variables. So you should have two scale or continuous variables. And then the next one is the correlation matrix, which will show you the correlation between quiz 1 and percent. So here it's listed as 0.818, and the little stars indicate that the correlation is significant. It also gives you the p-value. Here in APA style, this would be reported as p is less than 0.001. And it gives you the number of people that were used in making that calculation. So it doesn't give you the degrees of freedom as you would expect. So when you're reporting this, you should know that the degrees of freedom for correlation is equal to the number minus 2. So in order to report this, you would write R for correlation. You would do n minus 2, so 105 minus 2, so that's 103. That's your degrees of freedom. The correlation would be 818. And the p-value is less than 0.001 in APA style. To interpret a correlation, you should know that the number itself, or the magnitude, or how big the number is, indicates the strength of the relationship between the two variables. And this can range from 0 to 1, 0 meaning no relationship, and 1 meaning a perfect relationship. And then the sign tells you the direction of the relationship. So this is a positive number, which means that quiz 1 and final percent grade increase together and decrease together. If this was negative, it would be a negative correlation or a negative relationship, which would mean that as one variable increases, the other variable decreases. So you can actually put more than two variables in this analysis. So what I'm going to do is use all 5 quiz variables and final percent grade. So you go back into the Correlate Bivariate dialog, and I'm just going to add the rest of the quizzes and final percent grade. SPSS will remember my changes from before, so I'm just going to press OK. And now we get more descriptive statistics for each of the variables and then a larger correlation matrix. And I did this to show you that you don't need to request correlations individually, and also to understand how this matrix works. So along the diagonal here, you can see that the correlation is always reported as perfect 1. This is because it represents the correlation of a variable with itself. So this is the relationship between quiz 1 and quiz 1. Of course, because it's the same exact variable, it's going to have a perfect positive correlation. So all along the diagonal, we have a perfect positive correlation of the variable with itself. And then these off-diagonal values, here and here, represent the correlations between all of the other variables. This matrix is symmetrical, which means You can look at whatever side you feel more comfortable with, but you can ignore 1/2 of this matrix. So for example, the correlation between quiz 2 and quiz 1 is going to be the exact same as the correlation between quiz 1 and quiz 2. So this is repeated here. And that is how you request correlations.